All right, welcome to section 7.4. Today we're going to be talking about perpendicular bisectors. We're going to start out our notes by talking about the proof of perpendicular bisector. But in order to talk this proof, we have to review over some triangle congruency that you did last year in secondary 1. So what I'm going to do is I'm just going to take my notes and I'm just going to turn the page over to our last problem that we're going to do today, number 4. And then just down here, I'm going to write and review over our triangle congruencies that we learned last year in secondary 1. I'm just going to say special notes about triangle congruency. Now maybe you're like going, do I remember triangle congruency from last year? Well, it was things that we used to say that triangles were congruent. If I write this, SSS, maybe that will spark a memory that SSS stands for side, side, side. I can prove that triangles are congruent by showing that all three sides of each triangle are the same. In other words, if I draw a little picture here for a minute, I can say that this side, put the markings there, that if I have another triangle and its side is 1 and this side has 2, that these three sides are all the same, then I can say that the triangle is congruent. So we have a couple of other ones that also prove triangle congruency. Another one is called side angle side, which is SAS. Notice that it goes forward or backwards. It's exactly the same. For side angle side, that means it must have the included angle, so the angle that's in between the two sides. So again, I'm going to draw a triangle here. Pretty sad looking triangles, but you'll get the idea. And if I have this side and this side, and then I have this side congruent to this side, then the angle that has to be congruent is this angle that's in between them. So the angle in between the two sides is side angle side. Next one is angle side angle. An angle side angle will look something like this. We'll draw our triangles different now. Is if I have an angle, a side, and then another angle. So this time it has to be the included side. So angle, side, and then the included angle. So these angles are congruent, these sides are congruent, and this angle is congruent. So if those three pieces are the same on two different triangles, then we can say the two triangles are congruent or equal, meaning they're exactly the same triangle with the same sides and same angles. There's one more that we won't use this year, but you were introduced to last year, and that was angle, angle, side, or we can also say side, angle, angle. And this one looks kind of like this. Again, I'm going to draw myself a triangle. If I have an angle and then an angle here, then it would be a side here. Or I could say this angle, even though it doesn't look like it, and this side. So this, oops, I drew it wrong. This one would have to be right here. So angle, angle, and then the side that's attached to the double angle there would be it. Or you can go backwards, side, angle, angle, side, angle, angle. Now, in order for us to do the proof that we have to do today, we're going to have to prove triangle congruency using one of these 4 types of triangle congruency. And then once I've proven triangle congruency, then I can say that because 3 of the pieces are congruent, that means the rest of the triangle is congruent. And that is called CPCTC. So I'll let you write that down for a minute. CPCTC, so a C and then a P, then a C, another C, and then a T, and then a C. And what that stands for is corresponding parts of congruent triangles are congruent. So if you prove that 2 triangles are congruent, then you can say that their other parts are congruent. So if I prove that the sides are all congruent, then that means the other 3 pieces, their angles are all congruent. Or if I say the side and this angle and side are congruent, then that means the other two angles in the side are also congruent, that their corresponding parts will also be congruent. Okay, so we're going to use those ideas to help us in our proof. So first, let's just review over what perpendicular bisector says. We can turn back to section 7.3 and see that definition, or we can just kind of follow along here with this picture. Perpendicular bisector says that if I have a segment or a line that is perpendicularly bisects a segment, that then these two pieces will be congruent. Now if you notice, here's my perpendicular bisector. So perpendicular means that this is 90 degrees and it's bisected, so these two pieces are congruent. So they give us that CD is a perpendicular bisector of AB, and we have to prove that AC, so this piece right here, is congruent to BC. Now notice when we do this perpendicular bisector that two triangles are created. Here's this perpendicular bisector, and if I draw these two pieces right here, I have a triangle here and I have a triangle here. So what I'm going to do in my proof is I'm going to go prove that these triangles are congruent, and then once I prove that the triangles are congruent, then I can prove that their corresponding parts are also congruent. So here we go, follow along with me, and then we'll walk through it one more time after we're done. So first I'm going to write my given. So I'm first going to say that CD, and that's a line, so I'll put a line above it. CD is that, instead of writing out perpendicular, I'm going to use that perpendicular symbol as the perpendicular bisector of AB. Okay, that's what was given. That's my reason. Now what I'm going to say, because it is a perpendicular bisector, that means that this segment and this segment are congruent. So that's what I'm going to say next. I'm going to say that AE, I'll put my segment over it, is congruent to, and I'm going to keep corresponding pieces here. So A corresponds to B, so I'll say BE. And I can say that by definition, and abbreviate definition, of perpendicular bisector. Now also by perpendicular bisector, I know that this angle right here is 90 degrees, and I know that this angle right here is also 90 degrees, right? Remember, this is letter E. So if these two angles are both 90 degrees, I can say that they're congruent. So I'm going to say angle AEC is congruent to angle BEC. And again, my reason is going to be definition of perpendicular bisector. And they're both 90-degree angles. You don't have to write that 90-degree angle piece if you don't want to, but that's why they're both the right angles. They're both 90 degrees, so because it's a perpendicular bisector, so then that makes them congruent. So notice I've got a side and an angle, so now I just need to prove this other side. Now remember, here's my triangle and here's the triangle, so this side is part of this triangle on the left, but it's also part of this triangle on the right. So I'm going to say, kind of seems silly, but I'm going to say CE, so this line right here, is congruent to itself. Now you've used this last year, this property that says that you're congruent to yourself. I tend to think of it like when I look in the mirror, I see myself. That's how I remember what this is called, but it's called the reflexive, not the reflection, but the reflexive property. So sort of looks like reflection. That's how I remember. So reflexive property. So now I've proven that I have a side angle and a side are congruent to this side angle and side. I'll put a double there because that doesn't mean that those two sides are congruent. So now I can say, I'm just going to move this way, that triangle, and we'll go AEC, is congruent to triangle BEC. And my reason there is side, angle, side congruency. You don't have to write congruency if you don't want to, but I had room for it, so I did. But I still haven't proved what I need to. I need to now prove that AC is congruent to BC, but I'm almost there. I am there, actually. Because I've proven that these triangles are congruent. That means that their other parts are also congruent, that they're corresponding parts. So now I can just say that AC is congruent to BC by corresponding parts of congruent triangles are congruent. And then we could put our little smiley or our QED. We're finished with that proof down if we would like to. So that's the proof. Now, we've been kind of writing around this little paragraph right here. And if you notice, now that we'll pay attention to it, this is actually called a paragraph proof. It actually says what we just did in step function, right? We kind of did it as a table, kind of. It doesn't look very table-ish, but we tried to. But they just wrote it all in one paragraph. And if we follow along, it says because CD is a perpendicular bisector, well, that's what we said. CD is the perpendicular bisector then of AB, then AE is congruent to BE. Well, that's what we said right here. Because it's a perpendicular bisector, so by definition of bisector, they're congruent. Then it continues on. It says angle CEA, well, we did AEC. We just went backwards. Is congruent to CEB. We did BEC because they are both right angles. That's kind of what we said. Definition of perpendicular bisector is that as well. Then they said CE is congruent to itself, which is what we have here too, because of the reflexive property. This means that triangle CEA, again, we went backwards. We did AEC is congruent to triangle CEB. We did BEC because of side angle side congruency. Since the triangles are congruent, then all of their corresponding parts must be congruent. That's that CPCTC. So therefore, AC is congruent to BC. So that's our first time kind of doing a proof involving perpendicular bisector. You're going to practice it on your assignment, and we'll see it one more time, slightly different, at the end of our notes. So how do we use perpendicular bisector to help us in solving problems? Well, here we have another example, and they say that CD is the perpendicular bisector of AB. So we know that this side is congruent to this side, and now we just proved from up here that this side is congruent to this side. So see, I've got 8x plus 16, and we know it's congruent, that this side is congruent to this one, according to our proof that we just did. So that means I can just say that 8x plus 16 is equal to 24 because this is now the perpendicular bisector and these pieces are now congruent because we proved it. And then you just solve it. So you subtract 16 and get 8x equals 8, and so x will equal 1. Now you'll have a few easy ones like that on your assignment, and then you'll have some that are a little bit more exciting, like this one right here. And I'm going to zoom it up a little bit so that we can see the pieces. So it says lines L, M, and N are perpendicular bisectors. So I'm just going to kind of point out for a minute. Here's L, and it's bisecting QP. And here's M, and it's bisecting this base PR. And N, it's right here, it's bisecting RQ. And this point in the middle, they call it the centroid. You should probably remember that from last year. But what we're going to be asked to do is find X, Y, and Z. And then they're just telling us TQ right here is 2x, and PT is 3y minus 1. TR right here is 8, and then they put some more information that they didn't write in here. I've got this P to this point right here is Z plus 4, and this point from here to here is 7. So let's solve for X, and then we'll find Y, and then we'll find Z. Now you certainly could turn off the video for a minute and try it yourself if you want. I'm first going to work on finding X. So I see here's an X piece. If I choose this piece right here, this little triangle right here, that's got a Y, so that's not going to help me. If I choose this triangle right here, and this is the perpendicular bisector right here, so there's my triangle, and there's my two triangles right here, then that means this side is equal to this side, right? Do you see here's the perpendicular bisector, that's like this piece right here. And so I can say this piece, just like we had up here and here, 2x is equal to 8. And so x will equal 4. Now I'm going to move to find y. Now there's actually two different ways that I can see to find y. I can go back to this side right here and this side because this has 3y minus 1, so that's where I'm focusing. And for some reason I'm always drawn to this triangle. And now that I know what x is and 4, so 2 times 4, that means that this side is really 8. Or I could also look at this triangle. Here's this side and this side. And then here's that perpendicular bisector splitting them in half, so I can say this 3y minus 1. Oh, it equals 8 as well. So either way, whether I'm looking at this triangle or at this triangle, I get the 3y minus 1 equal to the 8, because here's this two triangles. This piece corresponds to this piece. And then I'll just simply solve it by adding 1. Gives me 3y equals 9, so then y will equal 3. Okay, last is z. So I see z plus 4 right here on this base. That's kind of this triangle right here, and here's the other triangle right here. So I'm looking at this greenish triangle right here. And I'm looking at this side, z plus 4, and it's equal to 7, because this is the perpendicular bisector, so these two pieces are congruent. I didn't have to think about corresponding parts. This was the perpendicular piece, so these two are equal by definition of perpendicular bisector. And then I'll just simply solve that by minusing 4, and z will equal 3. So you'll see some like that on your assignment as well, where you'll give you a picture, and you're just going to have to take some time and logically figure out what triangles you want to look at and what perpendicular, so that you can find the corresponding equal pieces that are congruent. All right, turn the page. So one last time, it says in brain research that in order to remember something, you have to do it at least 3 times, something that is difficult. And so this is our second time looking at a proof about perpendicular bisector, and then your third time you'll do it on your assignment today. Now again, you can pause this for a minute and see if you can come up with it, because just watching me do it is not necessarily going to help you remember it. Try not to flip your paper back, and just see if you can go from the given that this time it's a ray, BD, is the perpendicular bisector of AC, which is given. But this time you don't have to prove that corresponding parts are congruent. You just have to show that the triangles are congruent. So this is going to be a little bit shorter proof. It's not going to have as many steps. So I'll give you a minute to think about it. If you want to pause the video, this would be a good time to pause it, because I'm going to continue on in just a moment. So now that I know that this is a perpendicular bisector, I know that these two sides are congruent. So I can say AD is congruent to CD. And you'll notice that I'm trying to keep corresponding pieces, that A is like C on this triangle and D is like D. And I can say that they're congruent by definition of perpendicular bisector. So I've proven this side is congruent to this side. I'm now going to move up my way to the angle. This angle and this angle are congruent, so angle ADB, or you could say BDA, is congruent to angle CDB. And again, that's by definition a perpendicular bisector. A perpendicular bisector bisects into two congruent pieces and is perpendicular, meaning that it's 90-degree angles. So these angles are both 90, so they're congruent. And then I'm going to say that this side is congruent to itself. Put markings here, so BD is congruent to itself. BD, and again, remember how you're going to remember that property is that you just see the same thing on both sides, just like when you look in a mirror, you see yourself both ways. So that is the reflexive property. So I've got side, angle, side, side, angle, side. So now I can say that triangle, I'm going to write it their way, because that's how I want my proof to end. Triangle ABD is congruent to triangle. So A corresponds to C, BD, CBD, and my reason here will be side, angle, side congruency. I don't have to do any more. On the proof that we did at the beginning of our notes, we had to prove that one of the other pieces were congruent. So if I would have wanted to make this more exciting, I could have made it that then, rather than proving that the triangles are congruent, I could have said, prove that angle A is congruent to angle C. So once I got to here, then I could just say angle A is congruent to angle C by corresponding parts of congruent triangles are congruent. So that's CPCTC. Or maybe they would say, prove that this angle right here, angle ABD, is congruent to angle CBD. And again, I would use corresponding parts of congruent triangles. Once I've proven that I have a congruent triangle with 3 pieces, that means that the other 3 pieces are also the same. All right, good luck on your assignment. If you need to, reference back to your notes to help you in solving them.